Today on the Diesel Podcast, I'm going to be chatting with Matt, the founder of DFC Diesel, and he's going to chat with us about two parts of building an engine that's often overlooked or that local places may not have the ability to even be able to accomplish when building an engine. So I wanted to jump more into this topic, learn more about it. I don't know a lot about these two different areas of building an engine, but I'm definitely looking forward to jumping into that and understanding how, basic questions I should ask if I'm going to have an engine built. Before we get to it, I want to give a shout out to a couple of our sponsors that help make the Diesel Podcast possible. The first is Kershaw Knives. If you go to kershaw.kaiusa.com and use code TDP40, you get 40% off MSRP. So if you're looking for a knife for hunting, fishing, EDC, something around the job site, around the house, they've got you covered with a bunch of different choices for blade steel, blade shape, opening mechanisms, handle design, and a whole lineup of knives designed to meet any budget. So again, just go to kershaw.kaiusa.com, use code TDP40, and get 40% off your order. Also, if you're into other hobbies like myself, besides diesel trucks, you like to hit the range, go hunting, do competitions, if you go to targetsportsusa.com/dieselpc, you'll find Target Sports USA's ammo membership program, which is really cool, especially if you're ordering, more than a box here and there. For $99 a year, you get free shipping on any order, whether it's 1 box, 5 boxes, 20 boxes that you're ordering at a time. Also, you get priority notifications for anything that's in stock. Maybe it's hard to find locally. They'll notify you first, so you can get it headed your way. You get an instant 8% discount any time of year. That discount can also go deeper at different events or promotions they run throughout the year. You get notified of those first. Part of being a member is you also get entered for a chance to win 2 different giveaways that they do. The first is an all-expense-paid hunting trip to Colorado, so that includes airfare, accommodations, food, lodging, the fee for the hunt, complimentary meat processing, shipping back to you. It's a once-in-a-lifetime hunting trip that you're automatically entered for a chance to win. Plus, they also give away a brand new F-150 every year, so if you're looking to keep some miles off your diesel truck, need something to go point A to point B, want to build an off-road truck, do something like that, it's a giveaway that you're automatically entered for a chance to win as well. So go to targetsportsusa.com/dieselpc. You'll find all the details there. All right, let's get to today's podcast with Matt from DFC and talking about 2 overlooked parts of building a diesel engine. Matt, welcome back to the Diesel Podcast. I love having engine topics, being where the Diesel Podcast kind of all revolves around engines. And we were talking about something that's really overlooked in diesel and when it comes time to get an engine, and that's surface finishes and tolerances. And I don't know a whole lot about it. I just have heard, horrible stories people have said, or there's some of those jokes that go around where they'll show somebody like resurfacing a cylinder head with a wire wheel or something.
Yeah.
And, that kind of stuff. So look forward to chatting with you today.
Yeah, no, thanks for having me back. I mean, it's always nice to kind of like pull some of the data out of my head once in a while here.
Where would we start with these topics? I mean, because I think of an engine and all the components that are in it, tolerances just jump out at me like pretty much top to bottom. But for somebody who's listening that has a diesel truck, maybe they need an engine, or they're going to be needing an engine, or they just want to be informed, for when the time comes of, what should I pay attention to? Where do we start with that?
Yeah, I mean, it's a pretty broad topic. And I mean, yeah, it's even I sometimes wonder, like, where do you start with it? I mean, I think kind of the beginning of it is actually, there's a big difference between, I guess, what you would say is allowable from new, like from the OE, and then what actually works long term. Because I mean, in general, like the trucks on the road nowadays, they are lasting longer than they ever have before. But some things like a lot of manufacturers, I mean, it's happening in the gas world, and it's even happening within the diesel world to a certain extent, that they're trying to run tighter tolerances and thinner oils that at the end of the day kind of they do kind of help with like things like fuel economy and stuff. But the problem is lots of us are still towing 20,000+ pound trailers, and usually even as much power as these new trucks are making, everyone's still doing some type of aftermarket add-on and stuff. And so the bandwidth that some of the engines operate in is really shrinking. And so it's kind of you get stuck in a case where in ideal circumstances, will it last its 350 or 500,000 mile duty cycle, and if everything is done just right or whatever, I mean, you just start dramatically shortening the lifespan of that engine. So
my mind's going so many different places with questions to ask you about that. One that I just thought of was when you're looking at an engine, and I'm sure this will vary between older and newer, but what those factory tolerances are. As an engine builder, how do you decide I can tighten this up, or what should I do with the tolerances of it? And I'm sure through time, a lot of feedback and data and information kind of dictates that. But how do we, when you're building an engine, how do you approach that side of it?
I mean, like it's interesting because like when you start getting into the finite details of a lot of these engines, you end up where like they'll have what, like let's say they're saying like this is what a production spec is. So it's kind of, like let's say like, you could have a thrust bearing clearance that's between, 1 and 8 thou, but their worn out surface limit is like 35 thou. You could have main bearing clearances where factory production specs like 1.5 to 2.2 thou, but worn out's like 5.5. And so like I know a lot of these numbers might not mean much to some people, but it's kind of like saying, depending on the engine, sometimes they'll have it where they have a fairly wide area saying that's like, well, factory specs within this and this. And that's really just saying that when they're tooling up to do like 100,000 engines at a time, they might start at one clearance and then they don't have to like adjust tooling or replace cutters or do other things until they hit the opposite end of that spectrum or vice versa. So it's just kind of like that's where they're trying to operate in to do like massive runs, but I think that's sometimes where you could end up where, one engine's built a little on the loose side, one engine's built a little on the tight side on a certain clearance, which is why some might last longer than others, depending on, whether those type of clearances should have been, tighter or looser to begin with. So when you get into more of the aftermarket, like us, where we're, trying to remanufacture the engines, we try to go more off of like more of like a blueprinted spec. So we're like, well, we've identified, well, depending on whether it's a main or rod bearing clearance or it's a particular finish on a crankshaft or cylinder head or even the like the crosshatch surface finishes and the cylinder bores, we've essentially like overbuilding. I think we're over about 11,000 engines now, and you try and really focus on not always exactly like, well, this is what the OE says it should be. It's more like, well, what have we actually seen that is actually we've seen like the widest bandwidth of success over the longest period of time possible, and then we try and target every engine or platform for those specific specifications.
That's been a whole new kind of revelation in my in my truck journey or diesel truck journey. Because for the longest time, I thought whether it's Ford, GM, or Ram, they've achieved like the height of what manufacturing is, design is, and I thought that for a really long time. But I think through these types of conversations, it's sort of made me realize and understand that these are mass-produced vehicles,
Mhm.
and when they're being made for to sell however many are going to be sold and just streamline the whole process. Whereas in the aftermarket, somebody's calling you because they need something for a specific use, and you can really focus that attention to detail and the data that you guys have to be able to create a better product.
Mhm. Yeah, and like obviously with the OE, I mean they're always focused on, we're building a brand new truck, we're giving it, a 5 year, 100,000 mile warranty on, or may in some cases like 3 or 60,000 mile on engine or powertrains. And really their focus is just like how do we ultimately make it obviously last the warranty period without having any issues. Because like obviously uh a lot of like, whether it's the emission systems or some of the new oils that are out there nowadays, or even the service scheduling that comes up on the dash of the truck. I mean, none of those things are geared towards making that engine last longer. Like, for example, if you change your oil, based off what the you know that oil percent life in the dash tells you, you more often than not, you're probably going to more than halve the life expectancy of that engine. Um, because like that calculation that they base that percentage of oil life off of is really based on fuel. So they've been able to sit down and say, well, based on idle time, based on general usage and everything, when you hit 100% or get down to, I guess, 0% left on oil life, they've essentially already calculated saying this oil has pretty much lost all its lubricating properties and it's not doing the engine any favors at all anymore. But that's not to say that, the last 20, 30% was doing it any favors either.
That's a really good
Because
point.
I mean, for me, like I mean, if I'm if I'm like if you're regularly towing, hauling very, very heavy loads, you're running hot oil temps, everything else. I mean, your service intervals have to change considerably versus someone that's just like daily driving and everything else. But someone who idles lots, I mean, like I'm not sure if it's Ford or I think a lot of the OEs around the same amount, but they actually calculate it's about I think it's something like 40. Sometimes I get my kilometers and miles mixed up, so it's either 44 miles or 44 kilometers for every hour of engine idling. So they're saying that's like, well, every time you idle that's the equivalent of driving it, for 44 kilometers, let's say.
That's
Um,
I
and
never
so
that's
and
something I never thought of. I never the oil life tolerances, the engine, kind of everything fitting together is a really good point.
and I was gonna add the well, and like kind of another variable, like I guess like well maybe we'll focus a little bit on engine oils and grades and temperatures and stuff. As I mean, people don't seem to realize like how important it is to run the correct grade of oil for the ambient temperature outside. That's where like running like 540s in general is a good oil that you can use Canada, USA kind of year round. But anytime you're getting on the extreme side of it, like if you're getting on, extreme cold, even a 540, sometimes you can consider going to a 040, but I don't even like recommending that for if you're still towing really, really heavy loads, because you know, even in very, very below freezing temperatures, you can still get very hot oil temps when towing. So, then you have to decide, well, can I plug the truck in to warm the oil up? Do I have an oil pan heater? Likewise, I mean, I think we were talking just beforehand. I was just down in Phoenix where it was like 97 degrees already. And, you get into like, Arizona, Texas, Florida and stuff, and you start getting, 100, 110, 120-degree heat. At that point, you got to start almost getting into like the 1540s, 1550s, just because it's like, it's a, that kind of top or bottom 20% of temperatures that North America faces or whatever is very creates a lot of problems with these engines one way or the other.
When I think about a lot of the truck owners that I know, or a lot of the listeners, they're using these trucks for hot shotting, towing, different things like that. So they might go through a bunch of different environments, in the Southwest and, the Midwest and different parts of the country where that would be really crucial. And I'm sure with cores and things like that, you've probably seen the damage and what can happen to
Mhm.
engines, when it's not correct.
And and it's kind of tough us as a manufacturer. Like we do our best, but I mean, thank I for many of the any other manufacturer, like what the type of oil you run and what temperatures, really varies on the type of engine you're building. So, I can't necessarily just go out and say this particular grade of oil is best for all of our engines because, different engines, depending on where they commonly, um, like where they commonly wear out parts and stuff, I mean, vary quite a bit. And then even the brand of oil seems to play a huge part too. I mean, I don't really want to get into like, either recommending or denouncing different brands of oil, but I will definitely say like our own personal experience, what we've seen, just over the last 14 years or so. I mean, there are definitely some well-known brands of oil out there that it just seems like, man, they're hard on valve train parts.
It's the topic. Yeah, I was thinking a lot of questions we get. Somebody will say, "What type of oil do I need to run?" And I know they're looking for a quick answer to it, but I'm glad you mentioned what you did with. There's so many variances with the engine itself, the temperatures. Is it an older truck, a newer truck?
Mhm.
It's so hard to just have one answer for what you need to run.
Well, and like I said, I mean, like I like a lot of 540 oils myself. I don't like seeing anyone running 1030s in some of these oils. That I just it you have a pretty small window you can operate in both on the amount how heavy you're going to load that engine as well as the temperatures you can operate it in on an oil like that. 1540s for most of the engines, they're pretty good to even, getting down below freezing temps and stuff. But, some of them like you start getting into an engine like the 6.4 power strokes. Well, the only thing that lubricates the whole top end of that engine is what travels up the push rod. And so you run a thicker oil than that, and you could probably start that engine, let it run for 10 minutes, and you won't see any oil coming whatsoever up those push rods to lubricate the rocker arms. So that's why those ones just wear out so fast all the time.
I could see, I can't remember the name of this YouTube channel, but I was like in this loop for like a week watching this guy's videos, and he was traveling, he's in Alaska in winter to go, I guess, to the coast or the Arctic, somewhere up there. But he was showing just how cold it gets, and he had a 94 to 97 power stroke, and just how demanding those extremes can be on a truck. And on the opposite
Mhm.
side, heat and the ambient temperature, can definitely play a part. But how much do tolerances vary between an older truck, like say a first gen, second gen, early common rail, versus some of the newer trucks? Is there a big variation in tolerances with different components in different eras?
Yeah, I mean, definitely like a lot of the newer engines, I mean, like if we're talking about Cummins, for example, I mean, they've had a pretty consistent, their factory bearing clearance is around, you know, 2 to 3 thou bearing and main bearing clearance. And but as the trucks have gotten newer, one thing that, they've really focused on is really focusing on the finish of the crankshafts, because this happened in the old 12 valves, and I think there's even a TSB out or something on some of the newest Cummins about idle speed, because people don't realize that, like, I think with the exception of like the 6 liter or like the Ford engines with that really big, oil pump that they have, most of these engines don't make any oil pressure cranking over. So when you're cranking it over at 150 RPM, it's not making any oil pressure whatsoever. And they don't usually don't actually make it till about 450 RPM or sort of thing. I haven't confirmed that on some of the other ones, just some of the ones I've seen in the past, like some of the Duramaxes and Cummins and everything. But so the problem is like if you don't have a very, very smooth, let's say RA finish on the crankshaft, and you're like the idling won't affect it as much. But I mean, if you're starting to have it where it's struggling to make oil pressure, especially when it gets really, really hot out, like if you're sitting around idling at a low idle speed and stuff, and it's really hot out, I mean, there's very, very little film strength of that oil left to kind of help prevent where your bearings contacting uh, the crankshaft. Likewise, I mean, like some of the newer Fords, I mean, they're running pretty tight clearances from factory, and they're recommending sometimes to use a 10W30 oil, which I'm sure the engineers have probably sat down and figured out, well, in a stock application, it works fine. But, you add a lot of guys out there, even, you do an airbox and exhaust and, like a basic tuner or something, and then obviously go and tow the max GVW that thing was rated for. And I mean, those engines do just tend to have a lot of bearing issues afterwards because of it.
I, I'm seeing now why you brought up the topic of oil and how it's fitting into tolerances and then surface finish. And I don't know a whole lot about it. I know that there's like I'm genuinely curious about how it all fits together, because I think it comes back to with my engine, I want it to last as long as possible. That's why I bought a diesel truck, and with surface finishes, say stock versus what you're able to do, what are some of the differences or questions that I should ask if I either need an engine or I'm thinking about one when it comes to different finishes?
Like, sometimes I've actually found, to kind of put it in perspective a little bit, it's because even some of the knowledge that we've experienced over time, it might be a little bit anecdotal, but it's kind of really good real world observations. I think it was like over 10 years ago. I'd actually built a 6.4 engine for my own personal truck. And this is before we had bought our porting machine. So I'd got a set of cylinder heads ported, out of a company out of BC. And so we built the engine, we put it in, and the truck was, like 2010 6.4 with I think I had a Spartan tuner on it. So it's probably making some around, 500, 550 horse sort of thing. And I only had the things on for about 1 or 2,000 kilometers, and it was smoking white. And it ended up being where it was leaking coolant down inside some of the cylinders. There's a bit of porosity in the heads. So we pulled the engine back out, and we ended up having to like dismantle it because a bit of coolant had gotten in the cylinder and stained it a bit. So when we pulled it apart, I think with only like, I guess I use miles, like with like probably less than 2,000 miles anyways, the the load bearing portion of all the rod, like the rod bearing shells, actually had like a black patch about 2 inches wide where it was just a really dark, like dark charcoal color, while the rest of the bearing is kind of like that light cream color they normally are. And that was with an RA finish on the crankshaft of about I think it was around about 8 or 9 RA, which is pretty smooth. Like, I mean, in diesels and high performance, they usually call for a RA finish of less than 10 RA. And so we rebuilt the engine and then put it back in. And I think I put about, I don't know, 20, probably about 15, 20,000 miles on it. And ended up, luck would have it, ended up having, I think, an injector cut a hole through a piston. So pull it back out again. But when we had built the engine that time, we had really focused on bringing the RA finish as low as possible. So I think it went in and it was about 4.5 RA. So, I mean, you're not talking like big number differences, but going from 8 or 9 RA down to 4 is actually pretty challenging. And when we pulled it apart, so I think it was like same horsepower level, same tune, same everything. Those rod bearings you could literally put back in the package. It looked like brand new. There was like none of that dark charcoal rubbing or anything. So I guess like what people have to realize is that when you have the higher the RA finish on the crankshaft, think of kind of tiny little scoops or shovels that are standing up off of the journal, and they act like little scoops that scrape away that oil film strength. So the rougher it is, you effectively remove more and more of like that oil wedge that actually like that's what essentially you're making oil pressure for, is it's an oil wedge to support the loads between the bearing and the crankshaft. So if you start scraping that away, you can start having it where you'll make contact with the bearing against the crank. And in cases where the RA is still low enough, what effectively happens is the bearing will almost help remove the last of those little kind of scoops or whatever that are standing up off the crankshaft. And then afterwards, usually you'll get, decent life out of it, but you still took a bunch of wear or lifespan out of that bearing in the process. So I think that's at like, 500, 550 horse. You can imagine, some of the newer Fords, they're at 500 horse and 1,200 foot-pounds of torque. I mean, you put 35,000 pounds behind that thing and you have to have a incredibly smooth RA finish on that crankshaft. And obviously, and then on top of it, have sufficient oil volume to essentially prevent the bearing from contacting that crank.
When you see engines that, or maybe you're doing research development or cores or something like that, how much damage do you see on these core engines from where you could attribute it to one of the three things, either tolerances, the type of oil, or the surface finish? Is it something that every engine has and it's just a matter of how much and that's kind of the lifespan of the truck, or I guess maintenance and using the incorrect oil and more power than stock, and towing weight kind of factor into it? But I'm just curious what you see when you're getting like cores in.
Uh, it's like, actually, your question could probably lead out in about 10 different directions on this one. So try and rein me back in if I go too far off. Well, as far as factory goes, like, I mean, factory has, when you're looking at a generally stock or slightly modified engine, I mean, the factory engines, I mean, they have good finishes um, on the crankshaft and on, the cylinder walls. Some of the deck surfaces and cylinder head finishes, I would say, are pretty questionable sometimes. Like, they're definitely within tolerance or spec, but I think like factory allowable is like around 50 RA on a surface finish on a block on some of the Fords and stuff, and we try and keep it below 20, so tighten it up quite a bit more. Um, so I guess trying to finish off and like on the OE engines, like the finishes themselves are usually pretty good. However, a lot of the clearances are not very good. Like, a lot of them are way too tight in some areas, and in other areas they're probably a little bit too loose. But typically speaking, nowadays they're trying to go for running thinner oils and tighter clearances, which again just help with fuel economy and a lot of the other things that they're going after. Um, in the remanufactured world, I would definitely say finishes probably play a far larger role in seeing premature failures again. Because I would actually say probably about 9 out of 10 places at least that rebuild these engines likely don't even have the equipment to measure. Like it's shocking how many places like they don't own profilometers. And a lot of them like they could very well have like 20, 30, 40 years experience, but the materials that these blocks and everything are made out of have changed considerably in the last 15, 20 years. And so they've become, I guess you could say, a lot less forgiving like they once were to, you can't run rougher finishes in a lot of cases. Um, and because of like even talking about the roughness finishes on crankshafts and other things, there's a big difference between the 1989 Cummins that made 160 horse and like a 2024 Cummins that makes like 400 horse.
Oh yeah, yeah. There's so much that's different, and I'm glad that you had kind of transitioned where I was going with it into the aftermarket side because when I think of somebody who might have an engine that's failed, or they buy a truck and they the guy tells them, "Oh, I had the engine built, or I did this," and you're good to go. How important it is to investigate who is doing the work, the experience, and the technology and the tools that you brought up. I wanted to focus a little bit on that because to me, like all of this is kind of like pure magic that happens, and then a
Yeah.
crate shows up and there's an engine. But I really want to understand more of the type of technology that you and DFC use to be able to attain these tolerances or these surface finishes. What goes into that?
Um, like a big part of it, like I mean, even prior to us getting certified, so like we became ISO 9001 certified in December of 2023. So a big part of that is essentially having it where there's not a single step that happens in this building that isn't tracked, recorded, and documented. So essentially, like from the time we bring a core in, we have to document the condition of that core, every component in it. What was the cause of failure? We have to, track like, what's being discarded, why. Then, there's a lot of overlap throughout the building about the different departments from our head department, our crank department, where we do blocks, where we do a lot of the covers and tins. But as we start getting into things that require, excuse me, finishes and stuff, I mean, in the crankshaft department, so I mean, you know, when we're looking at a crankshaft, I mean, I'm probably pickier than 99% of manufacturers on crankshafts because a lot of the cranks that we get that have like little scratches and other things that are in them. I mean, we're usually grind to the next oversize and I think like we talked about in other episodes, I end up having to like renitride some of the cranks because of the
Yeah.
factory hardening. And so we always want to make sure that it's like the bearing surface like on the crankshafts is obviously absolutely flawless. And then we have to measure them to within like, a tenth of a thousandth of an inch. And then a lot of times we may very well have what the OE production spec is. And usually we're trying to tighten that up to a smaller window that we like to be in. Um, like a factory spec on some bearings might say like 2 to 4 thou is acceptable. We'll try and aim between like 2.5 and 3 thou, for example, because we don't want to be on the complete one end or other. And that's just part of the blueprinting process. From there, every single crank we would do, we have to go, it goes through multiple stages of polishing and then has to get physically checked with a profilometer, which measures the RA, the RK, the RPK, and the RVK of the surface finish to essentially make sure that depending on what it is we're doing, I mean, with cylinder bores, you have to have like obviously a deeper RVK to hold oil, but you don't want to have like a deep RVK. You want to almost have like a mirror or chrome finish on a crankshaft because you're not expecting it to really hold oil. You're wanting it to help form a wedge that supports um the load of the engine. So then we would measure like every single crankshaft, and even though like spec is less than 10 RA, typically we're um some applications, I mean, if it's below 7 or 8 is acceptable. Some we're trying to push closer to 4. And that just kind of plays in part of like, well, what's the, what's the application of the engine, what's it being used for, what type of oil volume is that engine designed to pump from factory? Because obviously some of them produce a lot more oil volume than others. And then, you know, I guess like what are the common failures we'd see in that engine platform? Um, so that's just on cranks, but then so we would document and track, like I said, every single surface finish on the crankshaft. But then when we surface a block or surface a head, we literally check every single cylinder head and every single block deck surface. And most of the time, a lot of the factory specs are like less than 50 RA. Like I said, our threshold's been less than 20 RA. And a better way to describe that is kind of like, when you're on the drag strip and you're running a mud train tire versus running or like running like like an actual drag radial. Essentially, the lower the RA, the more surface area you have to like hold the gasket in place, so you don't have a bunch of little voids. So it's kind of like the higher the RA is having like an all train or a mud train tire, whereas having a lower RA is like having a drag radial. Then when we get into the cylinder bores, then we would have to after we're done honing and we're done our plateau finishing, we have to check in 2 spots of every single cylinder bore that we hone, because a lot of these engines to be successful for the long term have an incredibly small window that you have to operate within for your RPK values and your RVK values, because essentially like we use total seal rings, for example, in all of our builds, and they're a very, very hard ring. And they have like, obviously a lot of benefits with having that gapless second. But when you're also going up a very, very hard block, you're essentially getting to where you need a very, very smooth overall finish and a very round cylinder bore. But then you also need a very deep valley, because the valley will hold the engine oil that helps kind of the oil actually forms a bit of a gasket between the ring and the cylinder wall. And plus you want to have enough oil that if you're over fueling the engine or the injectors aren't operating correctly, you're not going to wash down the load bearing oil film, which ultimately leads to cylinder scuffing.
Okay. This is I was thinking of, there's so many questions, and I don't want to veer off topic too much, but one of them is a different series of engines that you guys have. So with those and what they're designed for, either power level or use, this is where DFC is taking into account the tolerances, the surface finish, all those sorts of things. So an engine, say that I would use it 500 to 550 horsepower versus one a bit more, there might be differences in it, but through the experience and the data and the research that you guys have, that's where it might vary a little bit, and then also too with whether it's a Cummins, Duramax, or Power Stroke. So it's not just one value for all these things. They're very specific to how you're using the truck and what type of engine it is, and is it older, is it newer?
Well, and that's why we're always trying to, with customers, like, I mean, whenever someone's coming in and they're wanting to get an engine quote, I mean, there's always that, I guess, hesitancy. I find that there's some people that they try and downplay what they're trying to use the truck for. And, I don't ever want to sell someone an engine that they don't need. Like, someone doesn't need billet rods in a stock application, for example, or billet connecting rods, I should say. So we want to make sure that we're ultimately getting them an engine that's, going to be ideal for their application and give them years of, years of trouble-free service. And that's why we do offer like multiple levels of engines, is because it's actually beyond, like, when we're quoting out, let's say, a different build of engine, it's actually beyond just using things like, let's say heavy duty valve springs or heavy duty push rods, doing air piece or OptiTorque head studs, doing like heavy duty flex plates, billet connector rods, stuff like that. Like, those are all obviously bolt-on parts, but to still have a engine that's going to last and be successful with the customer, you do still actually have to pay attention and sometimes modify the values of, like I said, your cylinder finish and the cylinder bore, the finishes of the block and or the cylinder head and block surface, and then even like the surface finish of the crankshaft journals. And that's where, like I said, in stock applications, it may be fine to have a little bit higher of an RA finish in some, but it's kind of like the higher performance it gets, usually the tighter you have to go with those values.
See, and that's something whenever I talk about engines or somebody asks me about them, I've never heard that talked about. It's always been, well, do I need billet rods? What kind of valve springs do I need? Push rods, head studs, that sort of stuff. It's never been a part of the conversation to talk about these other components with tolerances and surface finishes. So I think that's an excellent point for people to think about, because I probably have some friends that are like, oh no, my truck's only a 500. Well, it's probably closer to 6 or 6.25, but they're trying to just, get this engine or this part, whatever it is, just to get by, so to speak. But there's so much more that goes into it with what you guys do, that's why you ask the questions and have the different series of engines for people to choose from.
Yeah, and again too, I mean, there's always kind of like that juggling act. I mean, like it within the industry, I mean, there's obviously millions of these engines out there, and so I mean, whether it's us or it's other companies doing them, I mean, I still like trying to share as much information as possible, because I mean, if we're ultimately all out there working for our customers, then we should be trying to ensure that it's like, whether we're successful or another company's successful, we want to see that happen as much as possible. Because I mean, I know like even with all the steps we take, I mean, we're still going to have warranties. I mean, people have bad days, or they um you know things happen. I mean, sometimes just even things malfunction. Like you could even have a profilometer malfunction, not give you the right readings or something one day, for example. But um where's it going with this? The um Sometimes I hate when that happens. It's like you kind of start going down one pathway and it goes off the other one.
It happens to me all the time.
Um but but yeah, like on these surface finishes and stuff, I mean, like for example, like I mean, I had a customer, like they were recommended to us from another shop that we've dealt with for years. And again, they're going through some oil consumption issues and a bunch of Duramaxes, and they reached out, and so they sent up one of the engines for us. And I mean, and the thing I was trying to communicate with him is like, we did an assessment on it, but I told him, I was like, well, I think I still, for example, wanted to give the shop that did the work the opportunity to make it right for him. So I was like, look, I don't want to remachine your block and say these are the things I found. As like, instead we'll assess it, we'll measure it, we'll show you like, well, this is what all the surface finishes are. This is what our recommendations will be to help solve your issues, and then I'll just return it to you, and you go back to the shop, and then if there's anything that we've written down that says that that maybe they're wondering, at least they're given the opportunity to see it as well. So I mean, because I hate getting into that game of where one company's trying to put down another to bring themselves up. So I'd rather I want to try and help out other shops and stuff, and make sure that they're successful and that they can do right by their customers too. So but yeah, I mean, so like I guess let's just use that as example, where it's like you know the company that would have like done, I think it's just like some machine shop somewhere, like I don't even know the name of it, but the sometimes it's just a shop that they likely have a good reputation. And he said that he's been dealing with this company for years, and he's always done good work, and then all of a sudden they have all these oil consumption issues and stuff, and they're not sure where it's coming from. And I was like, well, sometimes like smaller manufacturers or companies, like they have the best intentions, but a lot of places just don't know what they don't know. So that's why it's like, well, I'll take the opportunity to just share, like, here's some of our knowledge, and this is what we would recommend for doing this, and then give them an opportunity to try and fix it for their customer.
Yeah, I think that's also really important too, with the amount of knowledge and the tools and the expertise and the technology you guys have, is being able to tell other people about it, which is one of the reasons I was so and just really excited about this podcast, because I haven't really gone in depth personally with that, or didn't even understand a whole lot of it. To me, like I mentioned before, when I think of a built engine, it's billet rods and valve springs and push rods. I didn't know how important all these other kind of factors are. And there was one question somebody did ask me, and I think that would be a perfect time to ask you, is they'll hear this term blueprinted a lot, and they don't know what that means. From an engine builder perspective, when you say blueprinted, what does that apply to? What does that mean?
Well, I mean, my version of it is like, blueprinting is essentially like think of like whether you have blueprints for a house or blueprints for anything else out there. It's like this is the actual engineered design specification. So blueprinting, you're essentially trying to recreate exact specific measurements throughout that entire engine and essentially trying to remove that bandwidth of variance within it. So I mean, like a blueprinted engine, you'd want to have it where, let's say, like all of your piston protrusions are identical. They're not, all up and down all over the place, or like on a V8, you're not going to have one bank that's lower than the other. You're going to have exact repeatable, let's say, bearing clearances and surface finishes and stuff. So, blueprinting is really just about, far more consistency and going after exact finite details of the specifications you're after.
Okay, that makes sense. And would the next level of that be that ISO certification you talked about? Because that seems really in depth, and I know there's not a lot of places that have that. And so I just think of the detail and what you guys had to go through to get to that point. From you had mentioned the core coming in all the way through the whole process.
Well, and and a big part of ISO, like I mean, it's not something that's required. So I think it's like, we punished ourselves trying to get through the process. Like I mean, it was, it's a very expensive endeavor that took a long time. Like, it was probably about a solid year of working on it. And I mean, I have a couple of mechanical engineers that work for me as well and stuff. And I mean, they're working on it full time. They've been to obviously university for a bunch of quality assurance courses and stuff too. But the like we have thousands and thousands of documents. So I mean, jokingly, it's kind of like you almost like, depopulate a forest or whatever, building an engine sometimes. But what's nice though is like now whether it's right now or it's 5 years from now, we can go back and we know who touched what part, what the clearance and spec was, when we were actually building the engine, what it is now. So it's kind of like, now we have a very detailed means of essentially seeing, well, when we're assessing for, let's say, warranty damage or premature failure or something, it's kind of like, well, what was our production spec? And then what is the engine now? If you think like when they're building 100,000 engines, they can't tell you what every engine was. They're just saying, well, it's within this band with the specifications, because that's what their tolerances are. But they wouldn't be able to tell you like, well, this particular engine had a surface finish of this, had bearing clearances of this, had this, and all these other things. So that was a big part of what ISO helped bring us. An ISO can be as complicated as you want to make it to be. We have a big thing for us is like all of the steps in our building would have probably a minimum of 2 to as much as 7 people touch a part or a process or something along the way. Because like actually when we build our engines, it is a bit of an assembly line, but we have it where it's like, when the engine comes into our assembly room, it's about 80 feet long or so, and there's 4 stations set up where it's like, well, the first station would put in, the cam and crankshaft, but when it goes to step 2, they have to actually double check the first person's work, and then they do their steps, and then step 3 would double check step two's work, so on and so forth. And that was just a way to help, obviously, like, remove potential errors, or if someone like again, like, we're all human, so we got things going on in our personal lives. You start thinking about something that's not work related, next thing you know, they're daydreaming and they forget to tighten a bolt, and that can be a warranty. So we want to just try and remove as much possibility for error as we can at all times. And that's what, continuous improvement's really about, is just never believing we're actually, to a level already that, we have to assume everything we're doing right now is still wrong and we can make it better yet.
Yeah, well, and to be able to catch maybe a potential issue there versus a guy's truck in Florida or Saskatchewan or wherever they might be, if you can catch it there, that's where the whole process and the logistics and the time and effort
And,
that you
and
put in.
yeah, and what else was it? And like I've toured a lot of the really big manufacturers in the US, and I mean, all the ones I met have all been like amazing companies to talk to. And It's still funny though, as you talk to some of them and they're like, you know what, Matt, it's like sometimes we have it where 20 people touch something, they still miss an oil gallery plug. And it's just like how,
I think that's
and my analogy for that is like that, sometimes like if we don't kind of spot check, and we also try and do a lot of cross training, so we'll also try and have it where we can move a lot of workers around and they can work in different areas, because sometimes that'll help them stay more engaged in the job by doing new things once in a while. But um my analogy for how 20 people touch something that still happens is like, well, it's just because every person before and after that step assumed that the next person is going to do the job better than them.
I think what's so exciting about this and this type of conversation is I wasn't into diesel from the very start, but once I was an adult, got out of college and stuff, that's when I really started to pay attention and I started to love them. And I think back to how things used to work then and where we're at in 2024, and I've seen so many different scenarios play out. Like, you can have a friend that's like, hey, have this guy build your engine, he's down the street, he's great, and then somebody does it and maybe it's not great. So there wasn't that repeatability
Mhm.
and across the whole process. So to see where we're at now, what you guys are doing, it's such a breath of fresh air to see it in diesel now. 'Cause it's in other industries, or it has been in the past, but to see like the certifications, the details, the cross training, um, the data, and then being able to build different series of engines and all the details that we talked about today. I think that's what's going to help carry diesel into the future and hopefully bring more people into it. I don't
Mhm.
know if we've touched on it before, but sometimes somebody can have a real bad experience with a truck or a build or something like that, and then they just walk away from diesel trucks and they go back to
Yeah.
gas. And that's what we all want to avoid. So I think these processes are trying to combat that.
No, for sure. And I mean, I know I get asked all the time, like, well, it's like you're an engine builder. What engine would you recommend someone buying? And I've always told everyone, just buy the truck you like. They all break. At least if you like the truck, you'll justify the money fixing it.
I was going to ask you that earlier. What's the engine to get? But then I thought, well, you've seen them all break, so I'm sure it's like, what body style do you
On
like? What's the best deal?
Well, the tough thing is too, is I mean, there are definitely better and worse years of all models of engines, but at the same time is you could have a good model year engine and you could have a bad model year transmission or bad model year electronics or whatever else. So I mean, that's kind of why it's like it doesn't just really end at the engine. There's a lot of things going on with these new trucks. So that's why I just kind of summarizes saying buy whichever truck you like the most, because at least when it breaks, you'll more willing to spend the money fixing it. If you buy the truck someone told you to buy, it's like I knew I shouldn't have bought this thing.
I'm going to start using that when I get asked the question what truck to buy. So that'll definitely, I think that'll help me kind of direct people a little better, because I'm always hesitant to say I might like a particular truck the most, but I'm hesitant to tell somebody go get this one, because what if they don't like it? What if it's a lemon? What if it's just not a
Yeah.
good truck for them? I don't necessarily want to be responsible for that.
Well, and like one thing I would just definitely say, like, and so this relates back to, kind of like the overall finishes and the trucks and everything, and like this probably can't be underscored the most, but um, servicing and maintaining the vehicle as much as you possibly can is going to extend the life of any engine out there. It doesn't matter what make or model it is. So using good quality oil, using the proper grade of oil for the ambient temperature, and doing more frequent oil changes, like um, not to dive back into this too much, but something I don't think a lot of people consider too is like when you buy like a commercial truck from Dodge or Ford or Chevy, they typically have a lot less power, than obviously like a standard pickup truck does. But the other thing they also have is a lot lower gearing. So they'll come with like 488 or 513 gears. I don't think anyone's stopped to think that's like if you put on, let's say, like, I don't know, don't hold me as exact numbers, but they are, it just for illustration, but it's like, you put on 3 or 5,000 miles and you have 355 gears and a 35-inch tire. And, you put on 3 or 5,000 miles and you have 488 gears and a 31-inch tire. That one engine might rotate over like 1.5 million more times in the same amount of mileage. So it's like there's just that much more wear and tear that can happen, and especially if it's in an application that's more likely to be towing either hauling or towing its max load all the time. That's actually why they'll derate those commercial trucks a lot lower horsepower rating, because even the manufacturer knows at these horsepower levels, this thing is not going to last. And a person does have to service it a lot more, religiously, I guess you could say that, um, to try and prevent obviously things like fuel dilution, your oil going black, the soot that gets in the oil. And that's another reason why we also went to total seal rings, is like, I mean, it helps prevent a lot of the soot and fuel from getting into the oil. So even people that are extending the oil change intervals a bit longer, our engines are still going to last longer because of it.
That's a really good point. And I imagine there's a bunch of kind of broad topics that we've touched on, and somebody listening might have specific questions about one or the other, or maybe the different series of engines. Is the best place to get information about the engines you guys build, is it dfcdiesel.com? People can go there, find the information, and then if they need to reach out with something specific, they can either call in or send you guys an email.
Yeah, absolutely. I mean, like our website's getting a little dated. It's almost 10 years old now, but it definitely has a lot of information on it. Especially like we have a failure analysis section that kind of like highlights what the most common failures we see in all these engines are. Because I always find it's like, at least if, you know, how are we going to say we're going to make an engine better or prevent it if we don't know what causes it in the first place, right?
Yeah. Yep. That makes a lot of sense. Well, it was really cool to chat with you and go over these topics. There's so much going on in my mind of like other episodes and other conversations we can have, and kind of narrow it in. But it gave me a lot to think about, and questions to ask when I'm thinking of an engine or somebody's asking me about it and they don't know, they'll say, what questions should I ask, or what should I look for? So there was a ton of great information that you gave us, Matt. It was awesome to chat with you today. I know you guys have a lot of cool things coming up here in 2024 that I hope to be able to sit down and chat with you more about. But I appreciate your time today.
Yeah, no, thanks for having me. And yeah, it's always amazing how fast the hour goes each time.
Don't forget, Diesel fans, make sure and head on over to Kershaw.kaiusa.com. Use code TDP40 for 40% off MSRP. Great way to save some money, get some cool gear if you're in the market for a new knife for EDC or hunting, fishing, around the house, around the job site. Got a ton of different choices to meet any budget, a ton of different blade steels, blade shapes, handle design, opening mechanisms. We really appreciate them offering this discount code just for you guys. So again, just go to Kershaw.kaiusa.com, use code TDP40, get 40% off MSRP. Also, if you're into other hobbies besides diesel trucks, like to hunt, hit the range, do competitions, if you go to targetsportsusa.com/diesel PC, you'll find Target Sports USA's ammo membership program, which is really cool. So for $99 a year, you get free shipping on any order throughout that year, whether it's one box that you're ordering, 3, 10, 20, 50, however much it is. You also get an instant 8% discount. Different times of the year, that discount could be even deeper. So it's a great way to be able to save some money, not just on shipping, but also on the ammo that you're buying. And it's something that's exclusive just to members that they offer is a chance to win 2 really cool giveaways. The first is an all-expense paid hunting trip to Colorado. That includes airfare, accommodations, a fee for the hunt, complimentary meat processing, also shipping of that meat back to you. So you're automatically entered for a chance to win that. Plus, they give away a brand new F-150 every year. So if you're looking to keep some miles off your diesel truck, need a second vehicle, something to take off-road, it's a great opportunity for a chance to win a brand new truck. So go to targetsportsusa.com/diesel PC. You'll find all the details there. Also want to give a shout out to some of our Patreon supporters, Tyler Loewen at 23 Diesel, CUTTERUP Rob, J. Cole, Colby, all of our other Patreon supporters, all of you who subscribe on YouTube podcast apps, follow us on social media. We appreciate all your support here in year 8 of the Diesel Podcast, and look forward to bringing you more of the content that you want to hear in 2024. Till next time, keep the shiny side up.